Hi, in this video, I'm going to prove that the angle at the center is equal to twice the angle at the circumference. In this case, I'm going to prove that angle AOB is equal to twice angle C. I think at this stage, it'll be good for you to construct a diagram, a very rough sketch, so you work with the proof. So there's our first theorem we're going to try and prove is the angle at the center is twice the angle at the circumference. Does everyone have a diagram constructed in front of them?
Yes, sir.
Okay. So I want you to follow, even as we go and take a trip down memory lane for some of you. Now I need a strategy. And my strategy for this theorem is exterior angle of a triangle. So to start off, we need a construction. And our construction is going to be to join CO and extend it beyond point O, and we can name this point, maybe in this case, D. All right, let's talk about a construction. If you don't write a construction and you draw it, it is fine. If you don't draw a construction and you write the entire proof, you will get 0 for the proof. Any questions?
No, sir.
So very important is the construction. So construction, sometimes in an exam paper, they may do the construction for you, okay? Most of the time, you will have to draw the construction. So let's continue. You'll notice that I've also marked 1 and 2, indicating O1 and O2. Now remember, my strategy is looking at the exterior angle O1 and O2 and what they equal to. So you also don't have to draw, you have to draw the construction, but you don't have to write it down. Now, if O is the center of the circle, we know that AO, CO, and BO are radii, and that is, they are all equal. So we're ready to start. I'm going to start off by calling angle AX. Now, if angle A is equal to X, then we know that C1 is also equal to X. Now we need a reason for that. And the reason is, well, you can see an isosceles triangle, but our reason would be radii, angles opposite equal sides. Now if C1 is X and angle A is X, we know O1 is the exterior angle. So O1 is equal to 2X, X plus X. And the reason for that is exterior angle of a triangle. Now we're going to go on the other side and we're going to call B Y. So we're going to use the same technique as the other side. If angle B is Y, we now can conclude that C2 is Y. And we have a reason, radii, angles opposite equal sides. In the same way, we have angle O2 would give us Y plus Y is 2Y, and the reason there is radii, angles opposite equal sides. So we end up now with angle O2 is equal to Y plus Y, giving us 2Y. Now if we look at angle O1 and O2 and we add them together, we get O1 plus O2 is equal to 2X plus 2Y. We can pull out a common factor of 2, and that gives us 2 into X plus Y. So O1 plus O2 is equal to twice X plus Y. But remember, if we look at our diagram, X plus Y is indicated by angle C. So we can replace O1 plus O2, there's our O1 plus O2, which is angle AOB, and that is equal to twice angle C. And we've proved the theorem, angle at the center. Thank you. Okay, I just want to go back a little. All right, any questions on the first theorem?
No, sir.
Are we all good? All right. So remember, our first theorem is stating that the angle at the center AOB is twice angle at the circumference, which is C. So I used a very simple technique, which was an X and Y technique. And remember, the crucial thing we're using here is exterior angle of a triangle. So theorem 1, I won't call it theorem 1. We'll refer to it as now for theorem 1. That is our first theorem we've done today. 1 out of 4. Next theorem.
Thank you. Hi, in this video, we're going to be looking at proving the famous tan chord theorem.
Right, this is the famous tan chord theorem. All right. So before we start, quickly draw a rough diagram so you can follow on the proof. Let me know when you're ready to start. Everyone's got a diagram?
Yes, sir.
Okay.
No, not yet.
Yes, sir.
Yes, sir.
All right, give you another minute.
Not yet.
1 second, sir. Oh, God.
All right, I think we're ready to start. So in this theorem, we want to prove that the angle between a tangent and a chord is equal to the angle in the alternate segment, which is N. We're trying to prove that L1 is equal to angle N. Remember, in an exam, they can also have the L1 on the left. So L1 could have been here. And you would try and prove that L1, if it was on the left, is equal to P. So please note, it doesn't matter which side, okay? So we're ready to start.
Which states that the angle between the tangent and the chord is equal to the angle in the alternate segment subtended by the chord. In this case, we want to prove that angle L1, which is the angle between the tangent and the chord, is equal to the angle at the circumference, which is N, subtended by chord LP. So we're going to start off with a construction. And we notice that we have a circle with center O. So we're going to join LO and PO. And that in turn makes LO and PO the radius of the circle. And we know that LO and PO are now equal. So let's call angle N to be X.
Okay, first thing, look at the area on the construction. It should be join radii, LO and PO, and not AO and OB. Is that okay?
Yes, sir. Pardon, sir.
Yes.
So in past papers, there's another way to prove it where you draw a line from L and you create another point or this under, I guess, the circumference of the circle, then you join it to P.
Very true. Lots of ways we can prove this
Right.
theorem. I think there's about 3 different ways, all right? But for time-wise, we're going to go with this one, okay? Are you okay with that?
Yes, sir. I'm okay, sir.
Now if angle N is X, we need to find an angle in relationship to N. So we have angle O, which is the center, and we know that angle O would be 2x, and the reason for that is angle at the center is twice the angle at the circumference. Now we're going to triangle LOP, and you'll notice that the base angles would be equal. So we want to find angle OLP or PLO, and we will take 180 minus 2x and divide that by 2, and 180 minus 2x divided by 2 will give us 90 minus x. So we have OLP is equal to 90 minus x, and your reason is radii sum angles of a triangle. So we know that these two angles are 90 minus x. Now we want to get to N1. So to get to N1, we know
that angle OLM is 90 degrees. And the reason is that the radius is perpendicular to a tangent. Now, if OLM is 90 and angle OLP is 90 minus x, by subtraction we will have L1 to be equal to x. Now, in conclusion, we have n is equal to x and L1 is equal to x. Therefore, we have L1 which is equal to n, and that's what we intended to prove. Thank you.
All right, before we go on, any questions? No questions? Everyone understands this proof?
Yes, sir.
Yes, sir.
All right, so I used a different technique and the young man was correct. There's also another way, but I just want to reiterate certain things in this theorem. So basically what I've done in this, I started with x. Then I went, can you guys see my cursor?
Yes, sir, we can.
All right.
Yes, sir.
So if I called nx, what is angle O?
2x.
Why?
Angles at center.
Because angle
Angle at the center. Very, very good. So then we got a triangle, but it's an isosceles triangle because OL and OP are radii. So 180 minus 2x, some angles of a triangle, divide by 2, got your 90 minus x. And we know that angle L, in other words, OLM is 90 degrees because the radius is perpendicular to a tangent. So if this angle is 90, and the smaller angle here is 90 minus x, 90 minus 90 minus x will give you x. You don't have to show the subtraction. If that's 90 minus x, that has to be x to give you 90. And it's a simple way to prove this theorem. Would you agree with that?
Yes, sir.
Okay.
Yes, sir. Can you please repeat that quickly, sir?
Mr. Katide, is that you?
Yes, sir.
All right, no problem. So if you look at this, the most important thing, Mr. Katide, is that you must do your construction. You got to join L to the center and P to the center. If you do that, you got radii. Now, start off with N to be X. Then O is 2X because angle at a center. And then working in the triangle that you see there, 180 minus 2x, we're using some angles of a triangle to find the other two angles. Remember, the two base angles will be equal. So we've got 180 minus 2x and divide that by 2. 180 divided by 2 is 90. 2x divided by 2 is x. That's how we got a 90 minus x for OLP. And then OLM has to be 90. The reason is the radius perpendicular to a tangent. And if the small angle is 90 minus x and the big angle here is 90, your L1 has to be x, as I wrote it down. And that proves the theorem, the famous tan chord theorem.
Thank you, sir.
Okay, we're ready to move on to the next one.
Yes, sir.
Yes, sir.
Equal to n, and that's what we intended to prove. Thank you. Hi, in this video we want to prove the theorem that states that the opposite angles of a cyclic quad are supplementary.
All right, let's give you some time to construct a rough diagram. Remember, you're just drawing a sketch. Quickly get a diagram so you can follow me. All right, everyone's ready?
Yes, sir.
Yes, sir.
So we want to prove that angle A plus angle C is equal to 180. We need a strategy, and we're going to be looking at angle at the center. So for me to be able to implement this, I need a construction. We're going to join BO to DO. Now remember, if we're trying to prove A plus C to be 180, A plus C, we'll join BO and DO. If we're trying to prove B plus D is equal to 180, then we will join AO and CO. So let's move to our proof. Now we're going to let angle A be x. And if angle A is x, we can conclude that O1 is 2x. So if A is x, O1 is 2x, and the reason is angle at the center is twice the angle at the circumference. Now if O1 is equal to 2x, we now can conclude that O2 is equal to 360 minus 2x. Remember, this is a revolution or angles at a point. Now remember, we want to prove that A plus C is equal to 180. So we need to get to C. So we're going to find C by stating that C is half of 360 minus 2x. Angle at the center is equal to twice the angle at the circumference. So if this is 360 minus 2x, we're dividing that by 2, we're going to get our 180 minus 2x. We have angle at the center. Now we know that angle A was x and angle C we showed is 180 minus 2x. And if we add A plus C, we will get 180 degrees, which proves that the opposite angle of a cyclic quad are supplementary. Now, in the same way, by joining A to O and C to O, we can prove that B plus D is equal to 180 degrees. Thank you. Okay, that word here should not be simply, it should be simile, all right? Simile, in other words, in the same way, if we join A to C, sorry, if we join A to O to C, then we will get B plus D equal to 180. So very important now construction to state that we're joining B and D to the center O. Any questions?
No, sir.
No, sir.
6 marks. You can't afford to lose the 6 marks, all right, in the paper. One must come out. All right, we're moving on. Hi, in this video, we want to prove the theorem that states that the line drawn from the center of the circle perpendicular to the chord bisects the chord. All right, let's give you some time to quickly construct your diagram so you can follow me. All right, is everyone ready? Everyone's got a diagram there?
Sir.
Not yet,
Yes,
sir.
sir.
Not yet, okay. I'll give you another minute to construct your diagram. All right, are we ready to start?
Yes, sir.
Okay. So we're given a circle with center O, and we want to prove that AM is equal to MB. So there's our question, AM equal to MB. So we need a strategy. Our strategy here is congruency. Now for me to be able to prove congruency, I need to do a construction. So I'm going to join OA and OB. And you'll notice I have two triangles. And I'm now going to prove the two triangles congruent. So we're going to take triangle OAM and OBM. And we're looking for three things that are equal in these triangles. And also they must be able to give me one of the cases of congruency. So number one, we have OA equal to OB because of radii. Remember, O is a center, so we have a radius OA and OB. Number 2, OM is common to both triangles. Number 3, we have M1, which is equal to M2, which is equal to 90. Remember, they told us that OM is perpendicular to AB. So M1 and M2 are 90 degrees. This is a straight angle. So therefore, we can conclude that OAM is congruent to OBM. And we have a case, right angle, hypotenuse, side. Now, if these two triangles are congruent, we can now conclude that AM is equal to MB, which proves that the chord AB is bisected. Thank you. Now, that's our fourth theorem we're dealing with. Any questions on this one?
No, sir.
We're all good.
Yes, sir.
All right, my question to you guys now is, from the four, which one you think will come out?
The second one, sir.
The third or second, sir.
Third or second?
Second one, sir.
I just want to know what the feeling out there is. All right, if we're working with probability, if you learn one, you stand a 25% chance in terms of probability. If you learn two, you've got a 50%. But if you learn the entire four, you've got a 100% chance of getting your 6 marks. Is that a fair comment from a probability point of view?
Yes, sir.
All right, so we're going to get into we can now go into the actual geometry.
It's not looking good, bruv.
All right. So now, gentlemen, what are you seeing now?
So we're seeing the level 1 or 2 question.
Okay, we're going to do some warm-up questions. Warm-up questions mean calculation, all right? So we need to look at some of the warm-up calculation questions. So it's a tough doing geometry because you don't have a question in front of you. If you're in my class, you should have this booklet, all right? If you're not in my class, we'll put the recording and also put the PowerPoints up so you can get a question later. I want you to try and follow me. And if you have a stylus, you can work on your computer, all right? And use Tipex later to take it out, all right? Okay, let's look at the first one. So it says in the figure, RGS is a tangent. As soon as you see the word tangent, give me some of the theorems you know with tangent. Somebody tell me. Yes.
Tan quad.
What page is it in the booklet, sir?
So just follow on the screen.
Hey,
So
Page
so-
3. It's page 3.
Thank you, page 3, all right. Now, if you see the word tangent, now in a book, I want you to write down this word tangent, a quick bubble map. If you see a word tangent, which theorem should be coming to your brain?
Tan quad.
Tan chord, well done.
That-
That's why I said this is warm up. If we get all the theorems right, when we go to the heavy stuff, you're going to survive. Right, only one theorem coming to your brain. Give me another theorem.
Red tan.
Tan chord, radius, perpendicular, tangent, well done. 2. One more.
Then tangent from a common point.
2 tangents from a common point. If you don't know, please write it down. Get a bubble map, spider map, whatever you call it. When you see the word tangent, immediately that's what you should be thinking about. 3 theorems rushing to your brain. Okay, circle, center O. All right, please. This is the center O. They should have told us that. It's missing here. Right, so make a note that O is the center. If BC is equal to DC, it's marked for us. We have an isosceles triangle. That's what you should be thinking about here, isosceles triangle. Then you got CDS is given to be 40 degrees. And question 1 is to find angle BDC. So to find angle BDC, the first thing I'm going to do, I'm going to ask myself a question. What is, gentlemen, can you see my highlighter here, my laser pointer?
It's on the 40.
Yes, sir.
Very good. So first thing I would ask myself is, what is, actually, let's go back to BDC. We want to find BDC. So the question I'm going to ask myself is, what is BDC equal to? In other words, what is D2 equal to? Anyone can tell me.
B1.
B1. And what is B1 equal to?
D1.
D1.
Okay, for those of you who didn't catch that, D1, we're going to go frontwards. I went backwards, now I'm going frontwards. D1 is equal to B1, which means B1 is 40 degrees. And the reason there is tan chord theorem. And then I can find D2 to be 40 degrees. And my reason is angles opposite equal sides. So we finished the first one. The second one is to find angle C. Anybody who can tell me what angle C is going to be?
100, sir.
How did you get that?
180 minus 40 minus 40 because of angles of a triangle.
Well done. Some angles of a triangle. The next question is to find angle A. Anyone can tell me how we're going to find A?
We can work on O2.
Cyclic
So
Quad.
Hey, well done.
Yes,
Somebody
sir.
saw a cyclic quad. Let me trace for you guys who didn't see the cyclic quad. And what do we know about opposite angles of a cyclic quad? They are supplementary.
Add up to 180. Yes.
Come to the last one, O1. Anybody can tell me what O1 is?
So it would be 160.
160, sir.
160. And the reason would be?
Angles
Angle
of
of
center is equal to
center.
2 times.
Okay, so that was a good warm-up question. Any questions before I move on?
No, sir.
All right, let's go to the next one. So in the diagram alongside, we see parallel lines. They tell us ST is parallel to QW. Let's get our spider diagram. If you see the word parallel, what should be running to your brain?
Alternate angles.
Write it down. Alternate angles are equal. What else?
Corresponding.
Corresponding
Angles are equal. We're going to be looking for that. What else?
Co-interior.
Co-interior angles are supplementary. Okay. Right. There's our tangent. We wrote it out in the first question. We already know what a tangent does. Okay. We've got 3 theorems on the tangent. And it goes on. The first one there is saying us W1 is 70. Let's put that in the diagram. And they tell us Q3 is 30 degrees. Question 1, to find angle V. So I like to work backwards and then I like to go front. Can I find a relationship? Any angle has a relationship with V. Anybody knows?
Would not be S1 maybe, sir.
S1, why? What's the relation between V and S1?
Cyclic quad.
Cyclic quad, well done. For those of you who cannot see the cyclic quad, let me show it to you. That's a cyclic quad, T, S, W, V. So V and S1 have a relationship, they're supplementary. Now, let's come to S1. Is S1 have a relationship with any other angle?
70.
Yes,
70. Why? Why is S1 equal to 70?
Alternate angles.
Well done. So let's go frontwards. We solved our problem. So we know S1 is 70. And we said alternate angles because ST is parallel to QW. Then we're going to get V. V is equal to 110. And why is V equal to 110?
So because they must add up to 180.
Cyclic quad. All you have to say is cyclic quad TSWV. All right, let's move on. Q1. There's Q1. What is Q1 equal to? Anybody knows?
Isn't it 70, sir?
Q1 is equal to 70, but why is it equal to 70?
That is a
Tan
tan
chord.
chord theorem.
Tangent.
Tan chord theorem, the angle between a tangent, and there we have the chord SQ. And if you trace chord SQ, it subtends an angle at W. We got our 70. Q2. How can we find Q2?
It's 80, sir.
Angles
How
in a
did you get
straight line.
80?
Angles on a straight line.
Some angles on a straight line. Very good. Angles on a straight line is equal to 180. And we come to the last question, T1. How can we find T1?
Would it not be
It's
100?
opposite
sir?
angles. Yeah, opposite angles. Cyclic quad, sir.
Right, we're looking at
It's not-
cyclic quad, TSQW. And 180 minus 80 gives you the 100. Are we all okay? Doing well?
Yes,
Yes,
sir.
sir.
Okay, so we're going to go to the next question. In the diagram alongside, O is the center of the circle. Now, if you see the word center, let's write this word down on the page. It's gonna come up quite often. What should trigger your brain if you see center? Do you know any theorems with center?
Angles in a
Angles at
semicircle.
center.
Angle at the center, that's one theorem. More theorems.
Angle in semicircle.
Angle in a semicircle, second theorem came up, angle in a semicircle. More theorems.
And the chord theorem.
The chord theorems. A line drawn from the center to a midpoint is perpendicular to the chord, or the converse. So we see three theorems we need to actually remember when it comes to this word center. I hope you're writing it down. Now, what else do we know about a center? If you see the word center, think about radii. You'll always get radii. See, OB and OC are radii. So that means they
Yes,
will
sir.
be equal. So remember that. Good. But anyway, let's go on. Determine to reason the following angles in terms of x. So they're telling us that this angle B2 is x. They want us to find O1 in terms of x. So if B2 is equal to x, I'm sure this one is quite easy for you guys. We know that's our radii. Therefore, C1 is x. Angle,
180 minus 2x.
well done. Angles opposite equal sides. And somebody said 180 minus 2x because some angles of a triangle is 180. And then the next question is straightforward because they want us to find A. And we're going to use the famous
90
angle
minus
at the center, all right? And that gives us the 90. You just got a half. 180 divided by 2 is 90. 2x divided by 2 is x. So we're using angle at the center. Anyone that knows how we're going to find D?
Cyclic quad, sir.
Cyclic quad.
A, B, D, C. So we're going to take 180 minus 90 minus x. Now, some of you might have a problem with that, so I'm going to write that down. Remember, to find angle A, we should be saying 180 minus 90 minus x. And 180 minus 90 is 90, and negative gives you a positive. So that actually 90 plus x. Or a simple way to do it is, we want to get 180, 90 plus 90 is 180, then the x's must cancel off, and you should be getting a plus x on this side. Okay. Are we ready to go on?
Yes, sir.
All right. Let's read this question. It says in the diagram below, PQ is the chord of a circle. OR is perpendicular. Can you see that? I just want to highlight that.
Yes, sir.
And remember, they're telling us O is the center of the circle. They should have told us that. Sorry, that word is missing. So add that in. That O is the center of the circle. And then it goes on to say, if the radius of a circle is 13 and PT is 12. So let's come to, if this is the center of the circle, are there any theorems we can apply here?
Angles at the center.
Yeah, but we don't have anything to use angles. Yeah?
No, so the bisect the chord one.
The chord theorem.
Chord
Right?
theorem.
A line drawn from a center, perpendicular to,
Yes,
what does it do?
Bisect.
So that's very important for us to note, all right? Let me just erase that. So, therefore, we can come up with QT to be 12. And the reason why that has to be equal to that. Line from a center, perpendicular to the chord will bisect the chord. So that's how we're getting our 12 for OT. Now, the focus is to find PQ. So we now know PQ is 24. Are you happy with that?
Yes, sir.
Now, the next question is to find PR. If we're trying to find PR, now PR, we know PT is 12, so we can't go and find PR because we don't know what's TR. But to find TR, we need to know what's OR. So what would you suggest we do in this question?
So you first work out OT, sir. Then
Right, let's
you
stop.
can.
Somebody said, well done. We find OT. And what are we going to use to find OT?
Pythagoras.
Pythagoras. Okay, take your calculators out, use Pythagoras. Tell me what you get for OT.
5.
Hey, somebody said 5. 13 squared is 169 minus 12 squared is 144, giving you 25. The square root of 25 is a 5. 5 means come alive, all right?
Yes, sir.
So we got all 5. Where are we going to go to from there?
So you can say that OR, sir, is 13, sir, because of radii.
OR is 13. Let's make a note of it. Why is OR 13?
Radii.
Because of radii, sir.
Radii. Well done. OR is equal to OQ. So what is 13 minus 5?
8.
8.
Now, we know vertically opposite angles at that point, that's also 90 degrees. So that 90 degrees now gives me permission to use Pythagoras. So if I'm now looking, at triangle, we can now use Pythagoras. And somebody's mic is on. Mute that. Right. So we can now use Pythagoras and find the third side. Anybody found PR? What is PR equal to? (12 squared plus 8 squared). You must have a reason or you lose a mark. So you must have in brackets Pythagoras. You happy with that?
Yes, sir.
And what is 12 squared plus 8 squared?
208, sir.
208. So we're going to say PR should be the square root of 208. And what is the square root of 208?
4 times by the root of 13.
4 root?
13,
13.
Okay. So that's how we find PR for 4 marks. Any questions before I move on?
Sorry, sir. So you're speaking to Kirsten here, sir?
Yes, Kirsten.
I wanted to ask you, sir, not to be rude, sir, what's your lesson plan for today? Like, where are you going on from here? Are we going to reach metric work as well, or are you going to do that in tomorrow's session that you have?
No, we are. We're going to reach now. We're going to move a little faster. I just wanted to refresh the theorem, and hopefully people are remembering the theorems. This is metric work, just to let you know. Huh? The grade 12
yes,
paper,
no.
You're going to write the grade 12 paper. It's based on grade 11 and 12 work. I would say 50% of that paper you're writing is coming from grade 11. Okay.
Sure.
And 50% from grade 12. Remember, in grade 12 geometry, the only thing there is similarity and prop intercept theorem. The rest is coming out from grade 11. So very important to revise grade 11. Did that answer your question? Okay. So I am going to be doing some grade 11. Even the analytical, Keegan, Mr. Kirsten, even the analytical is coming out from grade 11. There's no grade 12 analytical. So this paper that you're writing is heavily from the grade 11 syllabus.
No problem, sir. It's not to be rude, sir, but I've seen these guys that are leaving because I assume they think it's easy now and you're not going to reach there in time. So
yeah, you see, yeah, you know, if I don't do the basics, then they're going to fall short on that paper. Trust me. Okay.
No, it's okay, sir.
I hear your point, Kirsten, because remember now in a revision session like this, remember we're dealing with boys from across all the grades. We're coming from a bottom set to a top set. So unfortunately, we got to start off and then get them there, right?
Definitely, sir.
But I hear your point. All right. Yeah, it's fine. If anybody wants to leave, it's fine. It's not a problem, okay? So, okay, so I've done some calculations questions, and I'm quite happy with the calculations question. Now I'm going to go on to the next level, all right? So we're going to now go on to the level that we're going to talk about proving. And if we talk about proving, we want to look at riders. Okay. But before I go to the riders, let's do one rider together. I just want to share this. Wow, gentlemen, can you see this new PowerPoint I got on?
Yes, sir.
Yes or no?
Yes, yes sir.
All
Yes,
right.
sir.
So, okay. So we're going to start this one. Okay, this is now looking at how do we prove, all right? So the first one was simple calculations. So it says ABC is a semicircle with center O. Now, immediately when you see this word semicircle, what theorem will come to your brain?
Angles in
Angles in
semicircle.
semicircle.
Sorry, I've got a question coming up. Does the PowerPoint include answers? I am the answer to this PowerPoint, so I'm answering all the questions. Am I right?
Yes, sir.
Oh,
So
yes,
there
sir.
will be no posting of the answers, but I will record this and post the recording up. Now, so angle at the semicircle is very important. So if you look at the diagram immediately, which angle will be 90?
C2 and C1.
C.
And yeah.
Look again.
Sorry, sir.
Which angle will be 90?
Which terms did you say you must
O2
remember?
and O3.
Sorry, sir.
Yeah, sorry. Let's take the questions. Yes.
Sorry,
Question?
sir. Which terms did you say you must remember when you're using the semicircle, sir?
Angle in the semicircle.
Okay, sir.
You know what's the angle in the semicircle? The diameter. All right. So remember the angle in a semicircle, just to, that's your diameter. So the angle that'll be 90 is actually C2 and 3, not C1. Are we all okay with that?
Yes, sir.
All right.
Yes, sir.
So I don't know why I'm doing all that, but anyway, let's get back to the question. And then they tell us we have a tangent. Can everyone see we have a lovely tangent here? And when you see a tangent, we spoke about that. Tan chord theorem. Two tangents from a common point. A radius is perpendicular to a tangent. And it goes on. It says as SO is perpendicular. Let's go there. So we have O1 is 90 because SO is perpendicular to AB. So we've got O1 to be 90. And they start off by telling us that KCB is actually equal to 25 degrees. Now, if KCB is equal to 25, which angle will be equal to 25?
CAB.
A.
Well done. Why is angle A equal to 25?
Tan chord.
Tan chord.
Well done. Now I can see you guys starting to apply it. What else do we know? Why would I conclude that C2 is 25?
Oh, okay, because
Alpha.
OA and OC are radii.
Well done.
Oh yeah.
Well, we also know this, am I right? No, yes, we did know that. OB is also equal.
Oh yeah.
So, just to reiterate that. Okay, you don't have the question up. I'm just showing you some of the strategies here before we go on to more proving, okay? So if we look at this question here, that we know that C2 and 3 is 90. Okay, would you agree with that?
Yes, sir.
Now, if C2 and 3 is 90, we also know O1 is 90. What does it make the red shape?
Cyclic quad things.
Cyclic.
Very good. It makes a cyclic quad. So we just proved that TOBC is a cyclic quad because the exterior angle is equal to the interior opposite angle. Good strategy to see how to prove something a cyclic quad.
Sorry, sir.
Yes.
Which exterior angle is equal to the opposite interior angles?
O1. Can you see O1?
Sir.
Is equal to C2 and 3.
Oh, yes, sir.
So we use the converse theorem now. We'll write it out. Just I just want to get going with this question, all right? Okay, I think I don't have this question, so I'm going to skip this one. Okay, gentlemen, I'm going to end that one. All right, and now I'm going to open a grade 12 similarity PowerPoint for you to get you just to get some remembrance of this, all right? All right.
Sorry, sir.
Yes.
So if you get time, so can you please like upload the memo, sir, for the Easter tutorial, sir?
Okay,
The
no
one on
problem.
tricks.
Remind me, all right?
Okay, I'll remind you. Thank you, sir.
All right, let's look at this question together. So we don't have the whole question here, but I just want to clarify some very important things on this diagram. Can you see AB is parallel to EC? Okay.
Yes, sir.
Patience. We're gonna get into past paper questions just now, right? I just want to get some I will call some and first, all right? So that when I go there, we'll be able to survive. Okay. So we have parallel lines. Can you see the parallel lines?
Yes, sir.
We also have a tangent. AB is a tangent. So the question here is to show that C2 is equal to D1. So in an exam paper, you get a question like this. And the problem is, where do you start? So the way to
start at C2.
Yeah, you can either start with C2 or D1. In other words, call one of them X. Doesn't matter which way you go. So in this case, I decided to call D1 X. And now remember, if D1 is X, I need to get to C2. So let's just put a dot here. That's where I want to go. So myself, I need to ask myself a question. What is D1 actually equal to?
A4, sir.
Somebody said A4. Why? Why is D1 equal to A4?
Tan chord.
Tan chord theorem.
Angle between the tangent. Can you see that? From that chord, you must produce an angle from the two endpoints of the chord from A and C, anywhere where it will meet on the circle. That means that angle will have A4 is equal to D1. Now, if A4 is equal to D1, remember where we're going to go to? We're going to go to C2. Can we get to C2?
Yes, sir. Alternate angles.
Alternate angles. Can you see? So you need a starting point in the exam. Always start with one of it. Doesn't matter which one. If you're calling that X, you must get the other one to be X. So I'm trying to teach you. Okay. All right. We're picking up some feedback. I just want to. Now. Okay, so that's what I've just done, all right? Now, the next question here, we want to prove that ACF. Now we come to similarity, grade 12 similarity. How do we prove that ACF is similar to ADC? So you need a highlighter. We need to firstly highlight ACF, which I've done in blue. Then I need to highlight ADC, which I've done in green. See, color makes it come alive, all right? You can see much more, it's much more clearer. Now, if we look at the blue and the green triangle, we need three things. Actually, we only need two. For similarity, we only need two because the third one would be some angles of a triangle. So let's start. Anybody knows the first one?
C2
Yes,
and
sir.
D1.
D1. No, A is common on both the triangles.
A what? You can't say A, I'll give you 0.
Oh, sorry, sir. A3.
A3 is common. That's a good starting point. Can everyone see A3 is common? I like that one.
Yes, sir.
Okay, don't worry what I wrote there now. Right, we got those two triangles. We're starting. A3 is common. Do we have something else?
C2 is equal to D1, proven.
Well done. We already proved C2 and D1. It's staring at us. C2 is equal to D1, proved above. Now, what is the third angle? That's very important to pick out. And a lot of boys do not do this in an exam. They can't pick out the third angle. So it's very important for us to pick it out. So if we go to the blue triangle, the angle that is remaining in the blue triangle is F1. Would you agree with that?
Yes, sir.
Yes, sir.
And if we look at our big triangle, we took A3, we took D1. So the one that is
C.
left over is actually ACD. Because we got to write it down for a mark. That F1 is equal to angle C1 and 2. And the reason will be some angles of a triangle.
Triangle.
And therefore, they are similar. And if they are similar, what does it mean to us? I just want to write this down. This is not part of, yes.
So please can you explain 3 again, sir?
No.
All right. If you look at the blue triangle, young man, can you see the blue triangle I got?
Yes,
that
sir.
small one. In the first one, we said A3 is common. So we've taken care of A3. In the second one, we said C2. Can you see that?
Yes, sir.
So left in the blue triangle. F1. Got it?
Yes, sir.
And if we look at the green triangle, in one we took A3. I'm on the green, all right? Then in 2, we spoke about D1. So what's left in the green triangle? That's your third angle. So we're looking basically, number 3 is the third angle in both the triangles.
Oh, yes, sir.
Okay. Now that was a question which we proved. But remember, whenever you prove similar triangles, what's the next question will be about ratios. So what is the ratio that's coming out from here? Take the first two, AC over the first two, which is AD. Agreed? What will the second one be?
CF over DC.
CF over
DC.
DC. I don't know how y'all got EC. Am I missing something? What's the last one?
AF over AC, sir.
Well done. If your triangle's not in order, you're going to get the wrong ratios. And you have to have a reason. What's the reason? Similar triangles.
Triangle.
Oh, that's wrong. I put congruent. Can you see that?
So must you name which
that was a deliberate error to make you see what's the difference between similar and congruent triangles.
Sorry, sir.
Yes.
Is it compulsory to show which triangles are similar? Because in the diagram, there's so many triangles.
What you mean? Is it compulsory to show? I'm not with you.
So you can move on, sir.
There's a question. You got to answer the question. All right. Now, this is a proportional intercept theorem question. So we're heavy into Kristen, you with us? Okay, we're going into now some proportional intercept theorem. Let's do a quick knowledge of proportional intercept theorem. Who can remind me, what is the prop intercept theorem say? It's a very basic theorem, and most people make it a big issue. I have no idea why. The prop intercept theorem is saying if you got two parallel lines, what is the prop intercept theorem telling us?
It says that AB over AC is equal to AD over AE.
So you said AB over AC is equal to AD over AE.
Yes.
Am I right?
Yes, sir.
What else is this prop intercept theorem could have said? It could have said AB over BC is equal to AD over DE. So that's what prop intercept theorem is. You know, we make this prop intercept theorem such a big thing. All you got to know, gentlemen. Yes.
So does that mean that the ratios of, like, let's say AB over BC is equal to AD over DE? Does that mean that the ratios are equal, the measurements are equal?
The ratios are equal. Can you see what I wrote down there? That's ratios, the fractions. Okay.
Okay. Cool.
Doesn't mean AB is equal to AD. We are now making a comparison on the ratios. Ratios, big word for fractions. Am I right?
Yes.
When we say a ratio is 2:1, we basically can rewrite that as 2 over 1.
1.
Or if we say a ratio is 1 over 5, sorry, a fraction is 1 over 5, that's the same thing as saying 1 is to 5. Are you all happy with that?
Yes, sir.
So anyway, let's return to our question. Just want to rub my board out. If I was in class, I would have got you guys to help me rub the board out.
Yes.
All right. Now, for us to prove this, we want to prove that AD is equal to 4AF. Any ideas where we're going to start? Okay, we're going to start with the ratios. Can everyone see that ratios? Did someone write this ratios down for me? AC over AD is equal to... All right. I'm going to ask someone to call out the ratios for me so I can write it on the next screen, okay? All right. Someone got the ratios?
Yes, sir.
Can I have the ratios?
So AC over AB.
AC over?
AB. AD, sorry, AD.
AD, sir.
AD, sorry.
AD, sir.
Is equal to CF.
Over DC.
Yeah. Over DC.
And then
AF over AC.
AF over AC.
All right, my writing is very untidy there. Let me just change that, make it a little neater. Because I'll have to post this on my YouTube channel. All right. Now, the question is talking about showing AD is 4AF. So do we have any ratios that have an AD on it?
Yes, sir.
Do we have any ratios
Yes,
that
sir.
have an AF in it?
Yes, sir.
So let's bring those two down. So we can make a statement AC over AD is equal to AF over AC. Now, which two, if you look at the diagram right now,
AC
what
and
don't
AF.
we like here? AC seems to be a thorn in the flesh, am I right?
Yes, sir.
You'll see AC is a thorn in the flesh, or am I only seeing that?
Yes, sir. I see it too.
Well done. Now, can we compare AC to AD or AF? Look at the diagram.
Is AC not equal to AF?
Is AC not equal to AF? No, but AC is equal to AO. That was given to us, all right? Okay, I don't have the original question. They told us that AC is equal to AO. But I don't want to bring AO in because AO is also a thorn in the flesh. I want to find a relationship between AC and AD or AC and AF. Now let's look at it. So if we're trying to find a relationship between AC and AF, we can't. Let's find a relationship between AC and AD. Can we find a relationship between AC and AD?
Yes, sir.
Yes, we can. Well done, because that's a radii. So what relationship can we find?
1:2.
Okay, very good. Let's use simple English. In other words, AC is half of AD. Would you agree with that?
Yes, sir.
Yes, sir.
Okay. If you know that, then we can go on. So, powerful statement we are making, right? And the statement we are now saying that, all right, let's block this one out because I'm going to do a trick now. We are saying AC is equal to half AD. Are you all happy with that?
Sorry, sir.
Yes.
So can you please explain how it's half?
Okay, let's go for it again. All right. The question gave us, this was given. The question told us AC is equal to AO. So let's call AC to be that Matthews. Let's call it M for Matthews. If AC
Yes,
is,
sir.
how long will AO be? Okay.
M, sir.
I think let's use a letter let's use a famous letter called Y. If AC is Y, how long is AO? Y.
Y, sir. Oh, okay, I see now.
But DO is equal to AO. So that's Y. So that means AD is actually 2Y. Therefore, we can say AD is twice AC, or AC is half of AD. Does that explain the point?
Thank you, sir. Yes, sir. Thank you, sir.
Welcome, young man. But anyway, now, so wherever there's an AC, what can I replace this AC with?
You can replace it with the half AD.
I can replace it with a half AD. In other words, I can now write this down as half AD over AD is equal to AF over half AD. Would you agree with that?
Yes, sir.
Okay, now that AD and that AD we can cancel off. And now we're going to cross multiply. We can now say AF, what's half times half?
A quarter.
So AF is equal to a quarter AD. But if we look at the top, they want us to say AD is equal to 4 AF. So to get rid of 1/4, we multiply by 4. In other words, 4 AF, and if we multiply 1/4 times 4, it will be equal to AD, which gives you the top. Are you happy with that question?
Yes, sir.
Yes.
Mr. Kirsten, are you still with us?
Yes, sir, I am. Yes, sir.
Are the questions getting more of a challenge now?
Yes, sir, it is.
All right. So anyway, let's take another question. Now remember, where are we now? We are focusing now on merging grade 11 with grade 12. Remember, in grade 11, you did circles. In grade 12, you did similarity. So if we marry both, it becomes very interesting, okay? I think I'm going to, I'm looking at my clock, is not looking too good. Let me open now some past paper questions, okay? So I'm going to shift that, put it on hold. Well, everything I was doing was past paper questions, just to let you know. All right, let me share this now. Okay, we're going to stop the share. Sorry, I'm just getting the next PowerPoint opened up.
Not looking good, bro.
Not looking good. What's not looking good?
Not looking good, bro.
Okay.
So is there any way to move the test till Friday?
Never. Don't even think about it.
Oh, gosh.
All right, I'm almost there. I'm ready to share this now with you. All right, sharing is caring. All right, what are you seeing now?
So you can see the bottom.
Sorry?
Example 14.
Right. Here's one example. It's called the Exemplar 2014 paper, right? So on the top, you're seeing a past paper question. Very quick, easy one. And then we're going to go down the line, get to similarity, all right? Okay, there it gets a little more interesting down the line. Right, let's start. In the diagram, A, B, C, D, E are points on the circumference of a circle such that A, E, there's our first key points we're going to highlight. You got to look for clues. You know, geometry is looking for clues. Parallel lines, we should be thinking alternate, corresponding, co-interior. Okay. And if you want, I'm just going to highlight those two lines for you so you can see it. Oh, looking good there. You can see a Z. You see a Z there. And then it goes on.
Sir.
I'm just going to read important information. We have a tangent, tan chord theorem. They didn't give us any centers, so we're ready to start. So the first question here is find E1. What is E1 actually equal to?
E1 is equal to B3, so.
B3.
All right, E1 is equal to B3, but we don't know B3.
It's equal to B1 too.
E1 is equal to B1. Well done. Why is it equal to B1?
Tan chord.
Tan chord. Well done. Now you're seeing it. All right, E1 is equal to 68. Then they want to find B3. Somebody already told us that. Alternate angles. Then we come to D1. Who can tell me what D1 is going to be?
D1 is equal to E3, so.
Why?
Cyclic Quad.
Yeah. We got some smart guys here today. They saw the cyclic quad. You see, it's about finding the clues, you know. 68. So I just want to change that color.
Angles.
So that's your exterior angle of a cyclic quad. Well done. E2. How are we going to get E2? Any ideas?
So that triangle one too. Exterior angles of a triangle, so whatever.
Talk to me. Hey,
68 plus 20. So
brilliant.
You're gonna
That
find
guy's
E3,
absolutely
sir.
brilliant. You know what? I don't know who that young man was. I wasn't looking at my Zoom speaker to see who's talking, but anyway, that's absolutely brilliant.
Sure, it doesn't. In the Monday, sir.
Hey,
It's
the
in
problem
the
with
Monday,
that.
sir. It is in the Monday, sir.
Let's draw it.
nah,
Let's draw it for guys who couldn't see it. We have to help everyone today, right? So you guys who
Including
cannot
Zane.
see that, we are saying that E2 is equal to 68 plus 20, giving you 88 degrees. And the reason, Mr. Who told us that answer? Matthews.
Sir, it's in the Monday, sir. In the
Yeah, we
Monday.
don't have it Monday in Cindy.
Sir, in the Monday in our class, sir.
No, he's not. Now,
Wow, sir.
so we go to 88. Now, some young men, they don't know how to use exterior angles, so they go find the third angle first. They would have found this angle to be 68, 20, 88, all right? Finding this E and then use some angles of a triangle. That'll be fine as well. Now, we're going to go to C. Well, cyclic quad, am I right? What will we get?
Yes, sir. We get 92.
Okay, that was a very easy question for a past paper. Okay, let's move on. Pick up the level. Now it gets a little bit more interesting.
Come on, Timby.
Now, we've got some motivators in the house. They are motivating their fellow
Please
colleagues.
keep quiet, Tepo. We're trying to concentrate.
In the diagram, M is the center. Keyword, guys. Keyword. M is the center. Let's go to the center. Actually, I want to put it in a red dot because red tells you stop and think. Before we go any further, it says you, okay, let's read first. Diameter AB. If they're telling us that AB is a diameter, immediately what should be coming to your brain?
E2 and 3 is a semicircle. Angle
Well
and
done.
semicircle.
So that angle has to be 90.
Yes,
But
sir.
if M is a center, I also know all the radii. Can you see this? All this radii I can pick up.
Yes, sir.
You see all the clues coming from one word. Then I'm also looking for angle at the center. And I can see angle at the center here. Who can tell me an angle at the center? We won't use it because it might, you know. But can anyone identify what the angle of the center would be equal to? Okay, I'll give you a clue. What is M1 equal to?
M1 is equal to X.
Oh, why will it be X?
It won't be X. That's not a T.
Oh, no. That's A, sorry.
Okay, I want to talk about that. If D4 is X, a tan chord, why is M1 not equal to X?
It doesn't touch the
it
edges of the
doesn't touch the
circle.
circumference.
Very good. M is not on the circumference. Well done. That's also a common error. All right. But anyway, we don't want to find anything. I wanted to know what is M1 equal to. I don't think you understood my question, but what I wanted you all to tell me, M1 is actually twice A. Did you see that?
Oh, yeah, yes, sir.
Angle at the center. Okay, let me show it to you. Angle at the center from B and D. Angle at the center from B and D, we got an angle called A. That's what I wanted you to tell me, all right? But anyway, let's move on. ME is perpendicular. Good word they're using, perpendicular, but it's marked for me in a diagram, so I don't have to worry. And we got a tangent. If I'm seeing a tangent, tan chord theorem, well, they're telling me this is X. So if D4 is X, angle A should be X. Am I right?
Yes, sir.
And it goes on, and then they say MB. And then we're saying MB is twice of BC. Let's look at that so we don't forget that. We might need to use that later on. So I want to mark that very quickly in green. MB is twice BC. So if we call, let's not use X, all right? Because we'll get confused later. Let's call it L for length. If BC is L, what will MB be?
2L.
Okay, let's make a note of that. Because later on we're going to forget about that. But let's underline it as well. So if we need it perpendicular, some key points, we got some tangents there. Okay, so we're ready to roll. All right, question 1. If D4 is equal to X, write down what reasons 2 other angles which are equal to X. Go for it. Who can give me the first angle, which is X?
A, sir.
A.
A is X, well done.
So wouldn't D2 be X, sir?
Okay, let's start with A first. Why is A equal to X?
Tan chord.
Tan chord. Well,
Tan chord.
then we got D2. Somebody said D2 was X, and you'll be totally right.
Yes, angles opposite equal sides.
Well done. Angles opposite equal sides. Remember, we got AM is equal to
MD.
All right, we got AM equal to MD. That's your radii. But your reason will be there. Angles opposite equal radii. Okay, let me give you some time to think about 9.2 because that's a proof question. All right, I think we can pick it up from there. So we want to prove that ME, there's a circle passing through MED. I highlighted that. So we need to prove one of the theorems exists. In other words, the converse. And the common one is normally, if we look at, in this case, the tan chord. So we know M3 is 90. If M3 is 90, which other, if there was a circle passing through MED, if M3 would have been, if M3 would be 90, which angle should be 90?
D2 and 3.
D2 and 3. Now we're going to ask ourselves a question. Is D2 and 3 90?
Yes.
Not D2 and 3, sorry, D1 and 2.
Yes, sir.
Yes, it is. So we know that D1, okay, I don't want to write like that. You might write down the wrong thing. We're going to call it, its name is actually MDE. MDE is actually equal to 90. Not because of M3 now. We said if that. MD is equal to 90 because the radius is perpendicular to a tangent. Would you agree with that?
Yes, sir.
But M3 is also equal to 90. Why is M3 equal? That was given. We have a case, therefore, MDE is actually equal to M3. Now, if M3 is equal to MDE, so we have the converse of the tan chord theorem here. You with me? Therefore, we can conclude that CM is a tangent, CMA actually. CMA is a tangent to the circle passing to MED. And what is your reason? Tan chord, but you're using the reverse, so you put the word converse on the top. Are you all happy with that?
Yes, sir.
Now my diagram is getting very cluttered. Can you see that?
Yes, sir.
Okay, so let me take out some things. So I want to erase something. Sorry about that. We might bring it in just now. So the next question talks about FMBD. We want to prove that FMBD so if I want to prove that FMBD is a cyclic quad, we're going to use the same principle. Anyone can help me out? So if there was a circle passing, what would M3 actually be equal to?
M3.
If it was a cyclic quad, M3 would actually be equal to FDB. Would you agree with that?
Yes, sir.
So we got to now prove that M3 is equal to FDB. So let's start with FDB. FDB is actually equal to 90 degrees. Why?
Because
we already, we already marked it there. Can you see that? Angle in there? Semicircle. But we also know that M3 is 90. Why is M3 90?
EM is perpendicular to AC.
Therefore, we can conclude that FDB is actually equal to M3. And therefore, well, we're going to copy and paste. There's a question. Let's copy that. Therefore, FMBD is a cyclic quad. And why is it a cyclic quad? We just proved the exterior angle of a cyclic quad, but we're using the reverse. There's no circle, so we say converse in front of it.
Converse.
All right. Are you happy with that?
Yes.
Yes. That, sometimes I want to tell you there's a nice way not to be rude to you. I don't have to repeat anything here. Why? You can watch the video again because this thing is going to be recorded. It's being recorded. So we don't have to repeat. Are you all getting that?
Yes, sir.
All right. Now, in tomorrow's session that I'm having on geometry, I will not be doing basics. Tomorrow we're going to be going directly into the higher level questions, all right? So let's now go to the next question. The next question wants you to prove that DC squared. Let's get DC. Let me highlight that for you. All right. It's saying prove that DC squared. So that's DC. Is equal to 5BC. Sure. Now, whenever we're talking about squares, straight away I'm thinking Pythagoras. So I want to draw the red triangle here. Do we have a right angle in the triangle?
Yes, sir.
Yes, somebody said. Which angle is equal to 90?
So D3 and 4, sir.
Well done. So we know D3 and 4 is 90 because a radius is perpendicular to a tangent. Now, how are we going to use that to prove that DC squared is equal to 5BC squared? Oh, somebody is writing. Motong is having a good time on my screen. Eh? I think I must kick him out of the lesson.
Come on, Tipo.
Now I can't erase that.
Yes,
Can you show me
sir.
messed up my screen? Where's this young
Come
man?
on, Tepo.
Let me
It's
get
being
him
very
out.
distracting. Hey, come, Tepo.
Let's give him a friendly warning. Before I take him out, I think he needs to delete that. Well done. Now, so what is Pythagoras actually telling us? Pythagoras will tell us that DC squared is equal to MD squared, am I right? Plus
Yes, sir.
MC squared. Hey, totally wrong. That's bad.
MD.
What is Pythagoras telling us?
That
Pythagoras
MD plus
Pythagoras will
MC.
tell us MC squared is equal to
MD squared.
MD squared plus DC squared.
DC squared.
Now, the problem is we want to equate all this to BC. So let's start with MD. What is MD equal to in terms of BC?
Radii.
Okay,
Right.
let's not worry about MD. We'll come back to that, right? Okay. What is BC in terms of MC? See, I've got MC here. Now remember they told us in the beginning, BC is L, and we said MB is 2L. So would you agree with me that MC is equal to how many of BC?
3 BC, sir.
3. 2.
Is everyone with me there?
Yes, sir.
In other words,
Yes.
if we call BCL, MC is equal to the whole thing is 3L. And you're totally right. So we can replace MC squared with 3BC. Got that?
Yes, sir.
Now we want to replace MD. Now
Well,
MD
that's
is
2 BC, sir.
equal to
2 BC.
MB. Can you see that?
Yes, sir.
But
Yes, sir.
MD is twice BC. So MD is actually 2BC squared. Agreed?
Yes, sir.
So that gives us 3 squared is 9BC squared. Now 2 squared is 4. Bring it on that side, it's minus 4BC squared, which is equal to DC squared. And 9 minus 4 is actually 5BC squared. Are you happy with that?
Yes, sir.
Yes, sir.
Just waiting for everyone to digest that. Okay. That's a good question, don't you think so?
Yes, sir.
So I'm gonna rub my board again. It's all messed up. The only problem when I raise all this, we miss a lot of things we proved above. Well, the next question is talking about similarity. And you're looking at DBC. And we're looking at DFM. Well, I think we proved, I can't remember, but I think we proved D4 was X, then we proved A to be X.
Yes, sir.
Did we
And
find
then
anything
D2.
about, we found D2, am I right? Because of
Yes, sir. Angles
the
opposite
radii.
equal sides.
Angles and,
Yeah, that was X and X. Did we find anything else?
No, sir.
We found a lot of right angles, am I right?
Yes, sir.
yes, sir, definitely.
Okay, so don't forget about that as well. That was a radii, that was a radii, and this whole thing coming down was a radii as well, okay? So we found a lot of things. But anyway, in this question now, we also proved something was, there was a tangent passing through. Remember that question?
Yes, sir. MB is a tangent.
Yeah, that solves our problem. If MB was a tangent to what? What was it a tangent to? MED, am I right?
Yes, sir.
So that also gave us a lot of angles, okay? So how can we prove these two triangles similar?
So could you say D4 is equal to D2 is equal to X because of We
We
proved
got
it
the
already,
first
sir.
one. Very good. We got D4
Yeah.
is equal to D2, which was equal to X. Okay, I have to write this down because in the previous question, we need to use this. In the previous question, we proved this was a cyclic quad. Would you agree with that?
Yes, sir.
Yes, sir.
FMBD. Now, if that's a cyclic quad, then that solves our problem.
Oh, B1 is equal to F2.
Very good. That's a cyclic quad. Then if we call this Y, then this will be Y. In other words, B1 is equal to F2. And what's the reason? Exterior angle of a cyclic
quad.
And then we got our last angle. Your last angle will be angle C, should be equal to angle M2. What's your reason there?
Angles of a triangle.
Some angles of a triangle. Okay, so we're going to stop there now. It's past, and we'll carry on tomorrow. Are you all okay with that?
Yes, sir.
Yes, sir.